Okay, timer time. Huh, I hate that. Anyway, 1.2 linear measure is our topic today. And after this lesson, you should be able to measure a segment and find missing measurements of segments by using algebraic equations. So we're going to do some algebra today. These are review questions, just some of the ideas that we kind of want to know about for our test or quiz on Friday. You sometimes, always, or never to fill in the blanks. These kind of questions can come up in the chapter. Intersecting lines. If lines intersect, are they coplanar? Are those in the same flat surface? Should I write on a flat surface? If I put it on your paper, does your paper represent a plane? It can, okay? So whenever you cross two lines, now just think there's no lump between my arms. The lines don't have a real thickness, so they kind of just go through each other, but they intersect at a spot. Any pair of lines intersecting can have a flat surface laid on it. This would be actually an always statement. They are always going to be coplanar. Now, if lines are crossing, it's saying, can you put a flat surface on them? Do you see a table? Have you ever seen a table with a crisscross? It's got braces underneath it. That's an example of intersecting lines. I know you don't have that. I know you don't. Sorry, guys. Yeah, you don't have that on your paper. I'm just trying to review a couple things, and we'll be right on to the lesson. All right, two planes, how do they intersect? Do they intersect in a point? This is going to come up on the quiz. Planes intersect in exactly one point. The wall and the ceiling are examples of planes. Can they be put together in one dot? No, never. Two planes intersect in a line. That you need to remember. Not a point, a line. 3 points are coplanar. Dot, dot, dot. Same plane, the way I just drew it, is a yes. They are going to always be coplanar, whether they're in a straight line or not. So this would be always. And then 4 points are coplanar. Now, if you have 4 points, I can do 1, 2, 3, but then I could have one out here away from the screen. Okay, so that isn't, you could have them in a straight line though, so then they'd be coplanar, or you might have them all on one little paper, but they don't have to be. So this would be sometimes are coplanar. Okay, and then there was this little tech thing, and I'll show you that. We got them right. Okay. All right, let's move on. So this is today's lesson. You do have this. This is where we're going to start filling things in. A part of a line between two endpoints is called a, what is it? That's it, line segment. You've heard of it before. Good job. Line segment. The lengths of segment, this is read segment MN. I'm just going to label this one MN. And RS, segment RS, you can write the letters above or below, it doesn't matter, are written as, now their lengths are MN, RS. You don't put the bar above it. This means segment. And when you see two letters without the bar above it, that means length. Okay, so if you're saying, what is MN? Then you would be wanting to know what the length is. Okay? All measurements that you make using a measuring instrument such as a ruler are approximations of the answer to the length dependent upon the smallest unit of measure available on the measuring instrument. Okay, what the heck does that mean? Well, on a ruler, it might be in centimeters or it might be in inches. This one is in centimeters. So it says find the length of segment MN. This thing is in the smallest unit of measurement is called a millimeter. And the big numbers, 1, 2, 3, and 4, the whole numbers on here are centimeters. Those long marks are centimeters. Those shorter marks are the millimeters, and there are 10 millimeters for each centimeter. So what that means is, if you count from 0 up to the 1, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It takes 10 little hops to get to the 1. That's what they're talking about when there are 10 millimeters for each centimeter. Now, if we want to measure this segment, this length is 10, 20, 30, and then 1, 2, 3, 4. So that'd be 34 millimeters. Okay. Or if we want to do it in centimeters, that's 3.3 is the whole number, and then 1, 2, 3, 4 marks after the 3.4 centimeters. Okay, and some of you, this is something you've seen a number of times, and you just totally understand this right away. Okay. The problem with measuring for students is generally in inches, not in centimeters and millimeters, because millimeters and centimeters are easier because it's all in powers of 10. Actually, and you can use decimals. When we get to the inches, like on the next one, we need to look at what kind of increments there are on the ruler. The rulers in my classroom in the back that I have in a bucket, they are in 16ths. And you need to know what that means. This ruler is not in 16ths. It's only in how many marks to get to the 1. So this is 0, 1, 2, 3, 4. So these are in quarter inches. Okay, every mark is a fourth. So this would be 1/4 of an inch. Then the next mark would be another 1/4, another 1/4, another 1/4. If you think about it, this is 1/4, this would be 2/4, which is 1/2. This would be 3/4, and the next one would be 4/4. You see how 4/4 reduces to 1? Maybe you've seen that before. And then every mark after is another quarter. Okay, so they're harder to do than the millimeters and centimeters. So the length of RS, what do we see it as? You know, and because of the way this is marked off, we have to use that particular mark right there. Okay, so it's going to be 1 and how many marks past it? 1, 2, 3. So this is 1 and 3/4 inches long. Okay, that's the whole 1, and then 3 marks past in quarters. You could have a ruler, and on your homework assignment there is one, where, say this was 1, and this was 2. And it might be from 0, it might have in here, let's see, I'm going to mark it up. What would that be? So this one is going to be 1, 2, 3, 4, 5, 6, 7, 8. So this one is in 1/8 of an inch. So it's in 1/8. Each mark is 1/8 of an inch. And then the rulers actually in my bucket that you use are in 16ths. And there are rulers that actually have on it 30 seconds. It's really hard to read them because the marks are so hard to. 30 seconds is probably as high as I've seen it go. Some instruments will measure even more accurately. The more marks on there, the more accurate you can be. Find the length of each line segment, but there's only so many you can actually see with your eye. All right, this segment, we notice that this is in centimeters. This is one of the easy kind. This is 1. If we want to do it in millimeters, it'd be 10, 20, and then how many marks pass? 5? That's good enough. So either 25 millimeters, or a lot of you might have already written 2.5 and then centimeters. Okay, that's great. The next one, this thing again is only got 4 marks from 0 to 1, so it's in quarters. So this is 1 and 1 mark past the 1, 1/4 of an inch. And obviously these are not to scale, guys. Okay, it's not like you could take a ruler and get the same answer. Then we got a pencil. We're considering the pencil line segment. There's this little, just so you want to drag down a vertical to the ruler. Why can't this be an 1/8? How about we split this thing up? I'm going to show you. Cut this in half. I cut every little place in half. Now I got it in eighths. See it? I just broke it up into eighths. So it's still going to give us the same answers if I didn't do that, but I want you to have seen something with eighths on it. So if I did this one, that's 1, 2, and 2/8. So if it was marked up, what would you write after you wrote 2 and 2/8? Reduce. It's 2 and 1/4. You see how it's the same answer that you get really from this diagram without making those extra marks? I just wanted you to understand some of them might be an eighth. 2 1/4. All right, and then this one's in centimeters, so you got to pay attention. You need a label on these. So that's 2 1/4 inches. This one is centimeters. So let's just go with 1 and, what do you think? 1, 2, 3, 4, 5, 6, 7. 1.7 centimeters, or 17 millimeters. All right, hopefully that's just a little review. And this last one, centimeters, one mark after the 3 would be 3.1 centimeters. Okay, new concept, or, well, actually not really that new. If something is between something else, so for example, this group of students is in the first 2 rows, then in here is 2 more rows, and then there's 2 more rows there. The group right here in the second and third and fourth rows are in between first and second and fifth and sixth rows. These are in between these two. Are they the same distance away from each other? Okay, this is wider, isn't it, over here than it is right over there? It used to be even, but now it's not. Okay. The point being, just because something's in between 2 other things doesn't mean it's the same distance from each one. Okay? That's very important. So being between, which is what betweenness means, a real number that corresponds to a point, that is the coordinate of the point. We're going to be talking about being between in just a moment. All right, points on a line can be matched 1-to-1 with the real numbers. That first statement there, all that means is that your number line is numbered in increments, okay, and you can count them. Okay, so where a real number is called its coordinate, and the distance between points A and B, written AB, absolute value of the difference. Does anybody know what difference means? What's that mean to do mathematically? Come on, someone knows. I know you do. Difference. Good job. Subtract. Okay, and that was Robert. Good job, Robert. Subtract is what they're saying. So here's how you can get it. And then you may have heard absolute value. That means the distance from 0. So if you take A minus B, after you do, you got to take the absolute value, which just means make it positive. So if it comes out negative, you make it positive. Or you can go B minus A and then take the absolute value. So one of those, either of those will give you the same answer if you take the absolute value. Okay, so now here at the bottom, when 3 points are collinear, you can say that one point is between the other 2. Okay, if 3 points are collinear, one is between the other 2. And this would be collinear points where C is between A and B. Here's some more examples of that. You have these on your paper, I believe. Yeah. So here, B is between points A and C. And this is a non-example. DE is not between D and F, okay, because it's not on the line. Now, this is a postulate, actually. It's called the segment addition postulate. It is very important in geometry. We will use this thing a lot. If B is between A and C, okay, what would that look like? Let's draw a little picture because it's down there. He has it early out. If B is between A and C, it's like this picture, but it doesn't mean that B has to be right in the middle. It just means B is somewhere in between A and C, okay? If that's the case, if B is between A and C, then the segment AB, you see here, it plus the segment from B to C would equal the entire thing, which would be AC, okay? That's what the segment addition postulate says. Add two segments that are in collinear and you get the bigger segment. So if AB plus BC does equal AC, this is like the reverse of that statement. If this is true, then B is between A and C. It must be. So look here, you see how those are? They're in the middle. You can tell which one's supposed to be in the middle just by the equation that you're given, right? The B had to be in the middle. It's in between, and the B would be in common to the two segments. Then you can drop the B's and you get the segment that they equal. All right, and this is just an illustration of that. So now we're going to use that property. The locations shown lie in a straight line. Find the distance from the starting point to the destination. So if we have to go from here to here, how far is that? Well, it's from S to R 64. From the rest area R to the destination D is 87. We need to put them together. And that's because SR plus RD is equal to SD. And so we're going to add those up and we get 151. And then we should label that in, what's MI stand for? Miles. And you can just write MI. So some of the problems are literally that easy. Then you might have one where you aren't going to add, you are going to do the opposite of add, which is subtract. So since JK plus KL is equal to JL, you can substitute in 15 for the JK, and I don't mean just kidding. Plus, you can think of this KL as an X. I don't know if that stands for anything on your texting. And then that would equal 38. Thanks, Caitlin, for acknowledging. All right. You can subtract 15 from both sides, and we get K to L is 23. And you guys, you do not have to write all of this stuff down to do this problem. I get it. I'm just trying to remind you of the segment addition postulate and that we're actually subbing in. All right, now, something else you need to know. Line segments that have the same length are called, oh, there's nothing on there. They are called congruent. If they have the same length, they are congruent. And there's a symbol for congruent. It is an equal sign with a wavy thing over the top. Sorry? Oh, okay. Did you need me to say so? Oh, never mind. All right, I thought you needed something. These down here, you see these little slashes? And that slash, those slashes mean something. Okay, it means these are congruent segments or equal in measure. Because they each have a single slash, it means that they are congruent. So in this diagram, AB and CD are equal, and this would say the distance from A to B is equal to the distance from C to D. The lengths are equal, or the length of AB equals the length of CD. The segments are congruent, come straight from that. If you have equal length, then you have segments that are congruent. And then with the bar on the top, that says segment AB is congruent to segment CD. So calculating measures, we start to apply this on line PQ to say that M is between points P and Q means that P and Q and M are collinear, and that the distance PM plus the distance MQ equals the distance PQ. Now it says that on line AC, AB is equal to BC, and they're both equal to 3. We can say that the segments are have equal measure, or you can say that segment AB is congruent to segment BC. Slashes on the figure indicate which segments are congruent. So the slashes matching mean they're congruent. On this diagram, PM and MQ are not congruent. But on this diagram, segment AB is congruent to segment BC. Only thing you can say about this one is that PM plus MQ equals PQ. Okay, so these will be the two types. We're going to be looking at different types of equations that we can write in just a moment. They may still need this page. I might be going a little fast on that. If I need to slow down, you just let me know. Okay, now we're going to work on a sketch. These are very different concepts. I want you to make sure this is very, very important that you get this straight right off the bat. Say that something is between. It does not mean B is in the middle. Okay? Does not mean that B is in the middle. It just says it's between A and C. So let's draw a sketch. So it says B is between A and C. That would mean A and C are on the ends, and B is somewhere in between. So make it clear that you don't intend for B to be in the middle. This only indicates that you can take AB plus the distance from B to C and put it together to get the whole thing from A to C. Do you need me to go back? No? Okay. Oh, thank you for, you know what? No one said anything about the fact that I changed the letters until 7th period today. This is the 3rd time. On the worksheets that I passed out, I changed this to a D, didn't I? And I'll tell you why I did that. So let's put in a D there, please, and I'll have to change my B's here to D's. I turned the sound off. I don't know, it's just humming. I don't even know who that is. All right. This says L here, right? Yours already says L, so I gotta be honest, I do have a reason why I just wanted to change it, because so many of them said A, B, and C. I changed it to D because I don't want you to think it's going to be alphabetical every time. It doesn't have to be, okay? So I changed this one to L just because I wanted to change it up and not use the A, B, and C all the time. So this does mean, it does mean L is in the middle. So I should have this as D. Does mean L is in the middle. It's very, very important to get the difference between these two topics. So our segment, it says L is the midpoint of AC, implies that L is right smack in the middle, and that we would know then that AL is congruent to LC, and you put those slashes on your picture. So what equation can we get from this one that's not the same as this? It actually is an easier, or not necessarily easier, it's just different. We don't need to say AL plus LC equals AC. We want to say something new. So if we're given a midpoint, we're going to say AL equals LC. The distance A to L is equal to the distance from L to C because of that word midpoint. A midpoint cuts a segment in half. We're going to use these concepts now to answer some questions. Point D is between E and F. Calculate the distance from E to F by adding ED and DF. This is an example. So we're going to take 1.2 centimeters plus 1.9 centimeters, and we're going to add. So if I do it without a calculator, 2 plus 9 is 11, carry the 1, I get 3.1, and that I would label in centimeters. Would you mind closing the door? Thank you so much, Alyssa. Thanks. I want to hear what they're doing in the hallway. Easy one. Now we got to do some algebra. All right, so that on to example 6. The whole point of this is, if B is between A and C, what we know is that AB plus BC equals AC. All right, and that's from your notes. Now, what I'm going to be doing often in geometry is I'm going to use something that we know, and then I'm going to take and trade X for AB. I'm going to trade 2X in for BC. And then I'm going to trade 2X plus 5 for AC. So I have to bring down the equals, and then I got 2X. Oh, I write my 2's different ways. 2X plus 5. It bothered some students, like one of my students last year. Try to make them the same. Okay, algebraically, we need to combine our like terms on the left-hand side. We need to then get our x's on one side by subtracting 2x from both sides. I'm just solving an equation now. And then we have x is equal to 5. So our answer is x is 5, and then it asks us to find A to C. So I go back to my diagram and I see that it has A to C. That's what this means. It goes from the end to the end. It's 2x plus 5, so we're going to do 2. We're going to plug in 5 for x. We're going to have 2 times 5 plus 5. And that's going to give me 10 plus 5, which gives me the answer A to C is 15. Okay, that's the algebra that you do in geometry. Very much, you know, the basic stuff. Anybody still need this page? Okay. And the measurement of each segment, and assume each figure is not drawn to scale. Okay, so this one's kind of icky in that we have a mixed number, but if we're going to find this piece right here, then we need to take 6 and subtract from it 2 3/4. Now you can do that on your calculator by typing, the hard part is if you start with 6 and you go minus 2, that would be one way to get going, but you also have to subtract another 3/4, 3 divided by 4, and then you'll get the right answer. You got to subtract both parts of the mixed number. You can't type 2 3/4 at once unless you convert it to a decimal first. Okay? You know how to convert 2 3/4 to a decimal? I bet some people don't, so I'll just show you. If you wanted to convert it to a decimal, you can do 2 plus 3 divided by 4. And I would give you, oops, it did not like what I just did. I know what's happened. All right, 2 plus 3 divided by 4. And I'll give you the 2.75, and then you could have said 6 minus 2.75. Now, it's kind of nice to answer in the same format as your original problem. So we got 3.25, so I would take that. Or What is that if you wanted to write it in quarters? 3 1/4. If you think of money, that's not all that bad to write like that. R to T, we're just going to add. This is a super simple 2 plus 2.5, which is going to be 4.5 centimeters. And then number 8 is using the fact that these segments are equal. If the entire segment X to Y is 6 centimeters, how big is each one? Yes, 3 centimeters apiece. Okay, now we're going to get to the harder part, which is still not all that hard. Okay, ready? We are going to draw a sketch of this situation, label it, and then we're going to write an equation and solve it. Some of you may not really need to do the drawings, but I tell you, I found for the most part, most students benefit a lot from drawing a picture. Okay, so it says, find the value of X and the distance from R to S if S is between R and T. So if S is between R and T, the ends here of this are R and the other end is T. Now, I'm not assuming just because it says between, it doesn't mean it's right in the middle. So I'm going to make it so it's not. Put S down there. And it doesn't matter where you put it. Label this RS 5X. I'm going to label underneath. And ST 3X underneath. And then R to T is 48. I'm going to mark that in at the top. And I'm making those little brackets that show we meant to go all the way from R to T. All right, now, reminder that the segment addition postulate tells us that RS plus ST equals RT. I'm going to substitute in now 5X for RS. I'm going to put in 3X for ST. And I'm going to put in 48 for RT. I'm going to add 5 and 3 to get 8X. Combine like terms. Divide both sides by 8. And I'll get my solution of 6 for X. Then I'm going to plug in 6 to find R to S. RS was 5 times X, so it's going to be 5 times 6, which gives me 30. Not too bad, I hope. Somebody need this page still? Okay, I will wait. Thank you, Cadence. Cadence, my apologies for forgetting yesterday to give you a pass you were supposed to get. Was everything okay? Okay, thank you. I'm sorry. Just wanted to let you know I made a boo-boo. I don't remember the lady coming in even and all right. Okay, number 10. Same process. I'm just gonna make a set. Ooh, I don't like how that came out. Aw, poor Seggy. Let's straighten it there. We can go bye-bye. All right, so I'm gonna again I made this too low. Oh well. What are in the end? RN T. S is somewhere in between. And I've got 2X for RS, 5X plus 4 for ST, and then the whole thing is 32. Okay, once again, remembering that RS plus ST equals RT, I'm going to add 2X and 5X plus 4 and set it equal to 32. Adding in like terms first, I get 7x plus 4 equals 32. Subtract 4 from both sides. I get 7x equals 28. I undo multiply by 7 by dividing by 7. And my final result is 4 for x. Now I need to substitute back in. It said to find RS. I look up here. I see RS is 2x, so I do 2 times 4 and get 8. Okay, try number 11, please. Just walk around a minute. Anybody not get that? I can go over it. So I'll kind of skip this one since I looked around and it looked like people were getting that correct. All right. Now, I understand that everybody doesn't have to picture. I saw some really good pictures and a lot of really neat handwriting and very neat diagrams. I was really pleased with what I was seeing. That's very nice. Okay, here's a different concept. So I saved this one. We've got to remember that this is not the same as what we were just doing. Midpoint means what? Middle. So what do we know about PQ and QR? They're equal. Okay, PQ equals QR. The distance P to Q equals the distance P to R. So we're going to substitute in what's labeled on the diagram. 4x minus 1 equals 3x plus 4. I have some wrong things down here. You have x and you have PQ, right? And what's the other thing you're supposed to fill in? PR? That's the one, be careful. Okay, so people often miss this one. The last answer, just because they think they're finding both the segments. So subtract 3x from both sides. And then add 1 to both sides. And x will equal 5. And then P to Q, we're going to substitute in 5 for x. We're going to do 4 times 5 minus 1. And that's going to give us 20 minus 1, which would be, 19. Now, check it out. It says find PR. You know what the big mistake would be? People will just plug it in here and write 19 down. But that's not what it asks. If this is 19 and this is 19, then P to R is actually 2 times 19 or 38. Okay, there's 2 more quick questions. Are these segments equal? A, B, and C, D? They both got 5 on there. Yes. Okay, all you have to do is have the same measure. And then this one, it shows these slash marks. So what we need to do here is say that 3x plus 5 is equal to 5x minus 1. The slashes indicate those segments are congruent. We're going to have to solve for x in order to answer the question. So we would subtract 3x from both sides. At least that's what I would do. And would have 5 is equal to 2 times x minus 1. We would add 1. Yes, did I do something wrong? Yes, ma'am. Good question, all right? I can tell from the diagram that these are equal, right? So that's a way I'm going to find x. And then I'm going to have to plug it back in and see if I get the same numbers, okay? So good question. I should have prefaced that. I was just kind of getting in a hurry. So this is, we're going to get the value of 3 for x, right? All right, now, if we plug in 3 times 3 plus 5, oopsie, is 9 plus 5, this is 14. And if you put in 3 here, you get 14. But if you put in 3 here, 9 times 3 divided by 2 is 13.5. So are these equal? Y, Z, and X, Y, it is no. Okay, so we had to find a way to get X and then substitute it in. Well, thank you for your time. Have a great evening. I'll